Well, this is the last installment, video lecture concerning Part K, which deals with electric force. And we have a couple of example problems on the board for you to look at, and I'll discuss with you shortly. I'll begin by pointing to the electric force law. The force that any two charges exert on each other is given by the equation KQQ over the distance squared. And suppose in a particular example, the electric force between the two charges is 200 newtons. But then, by some magical means, one charge becomes half what it used to be, and the other one, by some other reason, its charge value is tripled. And all at the same time, the distance between the two, the separation between the two, is made to be half of what it once was. What then would be the new force between the two charges? Well, we have the new force equation shown here. The new force is KQQ over our distance squared. One of the Q's is half of one of them. The other Q is 3 times the other. And the distance is half of the old. And you can see 1/2 squared downstairs give 1/4. 1/4 reciprocates to a 4 upstairs, cancels the 2 downstairs to give a 2, times a 3. Final product of the numbers is 6 times the parentheses, which is this number, this expression here, which is 200. Final answer is 6 times the parentheses, or 6 times 200. Final answer, 1200 newtons. Any questions? Well, you can go over and over again until it is clear. Otherwise, call me, email me. You can do that for any question you have about any of the video lectures or the notes. Now, there's another sample problem behind me. Let's look at it. We have two equal charges symbolized by Q and Q, separated by that many meters, just 3 meters. And we're told that the force that they each exert on each other is 2 newtons. Magnitude of the force, maybe it's an attractive force. Well, if they're both the same charge signs, then it's a repulsive force. So there's a repulsive force of 2 newtons that one exerts on the other and the other on the one. And we want to find out what must be the charge on each object, that charge being the same in both places. So we have our force equals KQQ, K times QQ divided by the distance squared. The force is 2, there's your K, there's your Q times Q, divided by the distance here squared. Solve that equation for Q and you get that number. Now this concludes everything that I wanted to show you in a video lecture dealing with electric charge and electric force. So now let's move on to the last of the 4 parts on which you'll be tested on April 8th. Parts I, J, and K, and then N, skipping over L and M. So let's go to part N. Not in this lecture, in the next one.